Hey guys, Mr. Anderson here with you. Today in geometry, we're going to be talking about section 11.3, areas of circles and sectors of circles. All right, so our objectives today, we're going to find the areas of circles and find the areas of sectors of circles. All right, so first of all, you may be familiar with this one. This was pretty famous here. The area of a circle is pi r squared. Okay, pi times r squared, which r is the radius, and again, remember the radius is from the center of the circle out to the edge of the circle. Okay, now keep this in mind. I'll point this out before we move further. Remember before we were talking about the circumference of a circle, and so remember one of the ways that you could remember that was the circumference was 2 pi r. And here's what, and if you notice here, if you look at the two, the area and the circumference, notice there's an r and an r, a pi and a pi, and a 2 and a 2. That looks very close to each other, and so people easily confuse those. So that, for one reason, that's why I like to use the circumferences and call it pi times diameter, so I'm less likely to get confused with this. And I can easily, if I know the radius, I can easily find the diameter. But here's a little trick to keep this in mind is remember the circumference is a distance, and in a distance your units will just be feet or inches or centimeters. But when we're talking about the area, remember your units are always inches squared or feet squared or yards squared. And so if you notice, because your units will always be in square units, pi r squared. Okay, so little thing to maybe help you remember that if it's pi r squared, that's when you're going to have square units, and so that's area. Okay, so if you do like to use the 2 pi r for circumference, you notice there's no squared in there, and so that's not square units, so it's not area. Okay, I don't know if that helps or not, but give it a shot. All right, find the area of the circle around in the nearest tenth. So remember our area is pi r squared. So all we have to do is we have to know what our radius is, and if you look here, hey, it's pretty straightforward. Area is 12. So the area would be pi times 12 squared. Okay, 12 squared is what, 144? And so we can just plug that into our calculator. We're just going to go pi. Where's my pi there? I think that's it, pi times 144. And so it looks like it's about 452, what did it say, to round to the nearest tenth? So that would be 452.4 feet squared. Okay? So 452.4 feet squared on that one. Okay, not too bad, right? Pretty straightforward. All right, next it says an outdoor accessories company manufactures circular covers for outdoor umbrellas. The cover is 8 inches longer than the umbrella on each side. Find the area of the cover. Okay, so we've got the same formula here. So the same formula is going to be the area is pi r squared. All right, so remember the cover is this outer circle here. So it did say the cover is 8 inches longer on each side. So you've got an extra 8 inches here, but you also have an extra 8 inches over here. So what we have to do is we have to add all of these up together. So I've got 72 plus 8 is 80 inches, plus another 8 would be 88 inches. So what's the distance? That whole distance all the way across is the diameter, right? So the diameter is 88 inches. All right, well, we're trying to find the radius, and so what do we do to find the radius? You just divide by 2. So the radius would just be 88 divided by 2, which is 44 inches. And so that's what we're going to plug in here. So the area would just be pi times 44 squared. Let's call that up on our calculator here. So we've got 44 raised to the second power, which is that 1936, and then we'll just go times second function pi. And so did it say to round it at all? It didn't say. So we'll just come on. We'll just go to the nearest whole number there. So we're going to call that, the area is 6,082 inches squared. Okay, good. Next, find the radius of a circle with an area of 58 square inches. So again, we're kind of doing the same thing for each of these types of shapes that we've been talking about their areas. We see how to use the formula for area, and now we say, hey, if I know the area, how can I find a missing piece? And so again, we're still going to use that same formula. So again, our formula area is pi r squared. All right, we're going to try to find the radius. We know the area is 58 square inches, so we'll just plug it in. 58 equals pi times r squared. And so since we're trying to find the radius, what I would do here first is we're trying to get r by itself. So if you notice, kind of think like how we normally solve algebra problems. We clear everything away from the variable that we want. So this is being multiplied times pi. So let's divide by pi. And so where's my calculator here? So we've got 58 divided by pi, approximately 18.46. So this is about 18.46 equals r squared. And then how do we undo the square? We take the square root. So we'll just take the square root of that number. And so I'm going to go second function square root of 18.46. And it looks like, I don't know if it said this to round it at all. It didn't say to round it. So I don't know why it wants to do that today. And so, calculators. And so, what are we doing here again? Oh, radius. So we've got our radius then would be approximately, we'll just round that to 4.3. How about 4.3 inches? Okay, so again, we use that same formula, but instead of plugging in the radius here and figuring out the area, we just plug in the area and we can find the radius. All right, sectors. All right, we want to find the area of a sector. Okay, so this is probably the most difficult thing in here, but it's very similar. If you remember when we were finding the length of an arc before, remember the length of the arc is the distance of this intercepted angle here. So from the central angle, this arc here, remember when we did the length of that and we basically set up a proportion? The length compared to the length of the whole thing, which is the circumference, would be the same as the degrees to 360. So it's kind of the same thing, and we still have the number of degrees over 360, but instead of length over the circumference, it's just our area of the small part over the area of the whole circle. Okay, so it's the same kind of a thing. If you, again, there is an equation, you know, if you take that proportion and then multiply by pi r squared and by pi r squared over here, these pi r squareds will cross out and this is going to be your equation. So if you want to remember that, fine. I just like remembering the proportion and then multiplying to get to here because I can remember that better for whatever reason. Okay, so let's see how this would work. It says find the area of the sector, round to the nearest tenth. Okay, so we're going to set up our proportion here. So remember the area of our sector, which is the blue sector here, we'll just call that A. So I'm going to say, like they've done, A over the area of the whole, where's my, I'm losing my pen thing here. There it is. The area of the whole circle. So that's going to be, the area is pi r. It told us r is 22. So 22 squared. So the area of what we're trying to find over pi times r squared would equal the degree of our sector, 135, over 360, the total number of degrees. Okay, and so now we just work that out for A here, and let's just call up our calculator here. And so what I can do here is I'm gonna do this, simplify it so I can rewrite some stuff. 22 squared is 484. So what this is really here is area is 484 pi equals 135 over 360. And so what we can do is, I should have left myself a little bit more room here, but 484 pi multiply top to cross out the bottom there, and then here multiply 484 pi. And so what we can do here is, you could either just multiply these all across the top and then divide by 360, or divide those by 360 and then multiply by 484 pi. Either way is okay. And so I'm just going to go 135 divided by 360 is 0.375, and then we will just go times 484 and pi. And so it looks like then our area there said round to the nearest tenth, I believe, and so that would be 570.2 inches squared. Okay? Feel okay with that? So again, it's just the ratio of the area of the small part to the area of the whole circle, and the degrees of the small part and the degree of the whole circle. All right, one more thing here. Let's look at this one. Pizza. Yay, pizza. Has a diameter of 14 inches and it's cut into 8 congruent slices. What is the area of one slice? Okay, so I'm going to try to do this as best I can here. More or less, there's your pizza. And I don't know about you, but the way I normally cut it up is I usually cut it into 8 slices. And so that would look something like this. You cut here, you cut here, you cut here, and then here. Okay, so there's 1, 2, 3, 4, 5, 6, 7, 8. There's your 8 slices. So what's the area of one slice? So what we're trying to do is we're trying to find out, what's the area of just one slice here? What's that? Just that slice. What's the area of that? Okay, so if you remember our formula here, the area of our slice over the total area of the whole pizza, pi r squared, would equal the degrees. I'll just say degrees over 360. Okay, we'll fill this stuff in here. Okay, so first of all, let's start with this over here. We need to find the radius. Well, it tells us that the diameter is 14 inches. Remember, the diameter is all the way across. So half of that would be the radius. So now we've got what? Area over pi times 7 squared. And then, okay, so now we got 360 here. How do we find the number of degrees in our slice? Well, remember, there are 360 degrees total in all of these, and we split them up into 8 equal parts. So all we have to do is take 360 and divide by 8. That will tell us how much each slice, what the degree is for each slice, and so 360 divided by 8. 45. So what we have is each slice is 45, has a 45 degree angle, so we're going to put in 45 here. Okay, now it's getting close to what we just had in the last section. 7 squared is 49, right? So we've got 49 pi on the bottom. And so just to get area by itself, we're going to multiply by 49 pi on the top, which cancels that out, but we have to do the same thing to the other side. So we multiply by 49 pi over here. And so then in the end, we're going to plug all this stuff into our calculator. So I'm going to go 45 divided by 360. So that's 0.125, and then I'm just going to go times 49 pi. So times 49 and pi. And so that's says nearest hundredth, and so 19.24. It looks like 19.24 inches squared. Okay, so there's your area of one slice of pizza. All right, well, I believe that's it. Appreciate you being here for 11.3, talking about pizza. All right, Mr. Anderson signing off. We'll see you next time in another edition of Geometry.